Good morning, mathematicians. We are doing, what are we doing today? We're looking at the wave equation. If my stream will pop up on my own channel. And then we'll look at the heat equation. And then maybe we'll get back to quantum mechanics. But I don't see that happening today. Today we're just going to try and understand why the wave equation is the way that it is. Good morning, Leo. Okay, the wave equation. Why is it like that? Maybe MathTube is just maybe YouTube's got a secret anti-math tube philosophy. Do I get to spread your GPA propaganda or your GA propaganda? I mean, you can try. Good morning, Arad. Okay, wave equation in one dimension. So something should be a wave if it satisfies this equation. Most famously can be derived for the case of a vibrating string. Okay, this I believe. This makes sense to me. And now from yesterday we understand a simple harmonic oscillator. What is the context behind us doing this? The pursuit of knowledge, Locke. The pursuit of knowledge and beauty and truth. That's the context behind it. What's the context behind it? The Big Bang. The universe began, and then a series of inevitable events plus some random fluctuations led to this moment. And all things will stem from this moment. All things before flowed into this moment and will flow forth from it. What do you need? Why do you need Leo's summarize? I just gave you the true context. Okay, yesterday we decided to look at quantum mechanics. Why did we decide to look at quantum mechanics? I don't know, because I felt like it. And quantum mechanics has differential equations. And then I naturally started wondering, what the hell is a differential equation? Yeah, so we got Hooke's law. The wave equation in the one-dimensional case can be derived from Hooke's law in the following way. Imagine an array of little weights of mass m interconnected with massless springs of length h. And the springs have a constant k. So we have a mass everywhere. And I guess the length is supposed to be the height between a peak and a trough. Is that the way that we're thinking about it? Part 2, huh? Mass m interconnected with massless springs of length h. Oh, sorry. Oh, the h is the... Okay, sorry. Right. The h is this way. Okay. Longitudinal versus transverse weights. Yeah, I remember learning about that in high school. I don't think I could even tell you the definition now. ux. Okay, the function will be the distance from the equilibrium. Right, so that will measure the magnitude of a disturbance. Mm-hmm. So by hook or by crook? By hook, the force at the location x plus h is this difference. Uh-huh. Wait, why though? I see, because the force... Right, the force is proportional to the distance, right? So it'll be that. Okay. Okay. Wait a second. So that's the... Okay. That's fine, I guess. But by equating the latter equation with this... Oh, but why are we... Okay, well, why are we doing that? Why are we equating the latter... Why are we equating the F hook and F Newton? Well, because I guess Newton is MA, so fine. Fine. Okay, sure. Fine. Yeah. Yes, that's true, Boris. That pitchfork is the dopest symbol. Do I know that F equals MA? Yes, believe it or not. Phonons? Why are we talking about phonons? Okay, so then the equation of motion becomes this. Okay. Now, if the array of weights consists of n weights spaced evenly over the length L, and the total spring constant of the array, then we can arrange the above equation to be that. And then we take a limit, and assuming smoothness, we get the equation. Why? Hang on. From the definition of the second derivative. I see. Wait, why is that the second derivative? You just surmised you poured some hot liquid. The quantized versions, anyways. Waves in solids are known as phonons. Oh, interesting. Okay, wait a second. Why is that the second derivative? I mean, the second derivative would be... well, you surmised incorrectly, Leo, unless you were talking of Boris. You surmised incorrectly this time. But maybe next time. Right, lim H, and then what? We've got the other... What am I going to call it? T, I don't know. Lim T F prime of F X plus H plus T. Ah, I see. And that's where the two things come in. So we get that. We get this minus f prime. Oh, I guess that can be part of the limit too then. X plus t minus fx over t over h. I see. I guess the only thing that needs to be justified is why this can be merged into a single limit. Somehow that comes from the smoothness assumption. But maybe it's physics, so maybe we can just wave our hands and say, oh, you know, whatever, I'll combine limits however I want, because we're just doing physics. Couperons? Hey, we'll get to your problem in a second. First, I need to help myself with my own problems. Yeah, how much more do I want to think about this? Okay, formally, algebraically, I see why that should be true, but how does one rigorously justify... this? What was your problem, Leo? Yeah, Leo, what's your problem? Yeah, weird. I guess it's fine. There is one rule when doing calculus and physics: rigor equals exercise for the mathematicians. Yeah, I guess I should put on my physics hat. But this does kind of bother me. Like, why? Assuming smoothness. That's probably the key. What can I say? I mean, if it's smooth, why would that allow me to change the order? I mean, I guess in some sense the second derivative, like, I guess what are you doing? You're swapping the derivative operator with itself, right? Oh yeah, so I guess right, smoothness, because I guess yeah, if you're smooth, then in general you can like swap partials. So you're just swapping the partial with itself, basically. Well, not quite. It's not just swapping it with itself, though. We're merging these two limits into one thing. Yeah, I don't see the precise reason. That's okay. Okay, I think Zafarb, I think Arad's answering your question. So that's the equation of a curve. Jacobian is not zero. Find an equation for the closure of the cone when Cx is the union of all the lines through the origin and points there. Just Fourier transform and be done with it. Yeah. Trying to do that specific example, but you can't seem to get the equation for Cx for some reason. Homogenization of polynomials. Okay, so maybe we do need to talk about homogenization of polynomials. Yeah. Ban Dayson, they were cheating with another math stream. Well, I noticed this guy, what's this Frank guy? There's this Frank guy who's streaming right now. And he gets way more views than me. So I don't know what I need to do. Yeah, look, here he is. This real now. Sylvan Franklin, that's this guy's name. So I don't know, maybe I need to be it made me think maybe I should start streaming. Maybe I should start streaming myself doing like Luffy problems or something. Um, oh look, he left. He left. Look, go spam his chat. Tell them to come watch my chat while he's gone. um, yo, physics cuber, how's it going? What if we skip the Schrodinger wave equation but barred K straight with the Dirac wave equation? We'll get there. We'll get there. We'll get there. We'll get there. He does stream longer. That's true. Yeah. Yeah. I think he also does more homework than responding to chat as well. So maybe that's what I should be doing. It can be easier to derive wave equation from Hooke's law if you do everything with differential forms. Do you have some sauce for that, Arad? You got a sauce? You got some sauce? Okay, let's talk about the projectivization. Let's talk about the projectivization of a curve. Let's talk about the projectivization of the Bitcoin curve. Right? Isn't it this? This one's a Bitcoin curve? Or is there an extra X in the middle? I forget. Anyways. So, Zafarb, well, do you know about projective space? Do you know about projective space? That's the question. Because projective space. So let's say the real projective plane. Good morning, Ken. Fellow infinity liver Ken. Although I haven't signed up for that stuff yet. My attention has been other places. So let's say I don't know, RP3 or CP, whatever, CP3. I'm so CP right now. CP stream. What is this? This is going to be. Let's do this. This is going to be all equivalence classes of points, where of course x1. Technically, I don't need to explain projective space to do this, but 2 points will be are equivalent. So all the points that are equivalent to x1, x2, x3 are just all the non-zero scalar multiples of that point, right? So, for example, what the projective space. So if you think about what's happening, okay, I just wrote down the 3D one, but if we think about 2D projective space, or sorry, we think about 1D projective space. That's where we're doing this relation in R2, right? And so what are we doing? We're just, if we're saying that 2 points are identical if they're scalar multiples of each other, we're saying 2 points are identical if they're on the same line. So every point on the line, every single line can be represented by, say, a point on the unit circle. But then we notice if we draw like a line through the origin here, then 2 points. Yeah, I should have said lines through the origin. We see we get some double counting. So actually, it's just sort of this top half of the circle, except actually these 2 points are identified, and so it actually is a circle, geometrically at the end of the day. What is going on for RP3, the one I drew above? Well, again, in the same way, every single point can be represented by a point of unit distance, right? Take a line, just take a line through the origin, take a point on that line of unit distance. That's a point representing line. But again, if you draw a line through the origin, pretend that one through the origin, of course, there'll be 2 points. So now you can get rid of the lower half, and so you just have the upper hemisphere represents everything. But of course, 2 points on the equator will be identified at intipital things. So in other words, the real projective plane, RP2, you can view as this space. It's this disk, except it's sort of like Pac-Man world, right? If you approach the disk and hit the boundary here, then you pop out on the other side, right? Um, okay. What else we got going on here? Don't wait until you're too old, though. Yeah, yeah. No, it's just I'll wait until like the summer or something. I also need to figure out where I'm gonna be the next couple of years. You know, I also didn't know, was I gonna be in Europe soon, or turns out the answer is no. But I know. I said you don't really need to define projective space, but I think it's um, yeah, stereographic project. Well, yeah, I guess that's actually more relevant to this problem. But okay. But let's imagine. So if we're in affine space, right? You know, real numbers. We want to define some curve in the real numbers. Some curve in R2, like the Bitcoin curve. Uh, you know, we can just define this equation, and you can just ask for the curve that's the zero set of this equation, and it probably looks something like this, right? Or maybe it's the separated piece of the curve. I don't know what it looks like for this one. Is Pac-Man toroidal? Yeah, right. Sorry, Pac-Man is toroidal. But now let's suppose we wanted to suppose we're working on projective space, right? So either that could be S1, or it could be this real projective plane that I just drew. um, and we want to do algebraic geometry, so we want to do polynomial equations on there. Well, if we think about, we want our polynomial equations to be well defined, right? So if we think about RP1, for example, how do I represent it? Well, it's these equivalence classes of points. So sometimes it's x, you start counting at 0, right? Sometimes it's these equivalence classes of points. And so, you might want to write down a polynomial f from RP1 to the real numbers, let's say. And you want this, we have coordinates. So we want some sort of polynomial in the coordinates x0, x1. But of course, if we had a polynomial, if we defined it to be, say, x0 plus x1. Actually, wait, maybe this would be well defined. So maybe this is a bad example. Well, no, it wouldn't be. It wouldn't be. Well, what am I trying to say here? Yes, exactly. That's the yeah. Um, yeah. I mean, that's basically the idea. I'm taking the most long-winded approach to um, I'm taking uh, the most long-winded approach to explaining this. Um, well, I guess this isn't well defined as a function, right? Because like for example, for example, f at 1 1 is equal to 1 plus 1, which is equal to 2. but the 0.11 is equivalent to the 0.33, which is 3 plus 3, which is 6, right? So we don't get a well-defined number out of this. But if we're asking for, suppose we want to write a polynomial, so in the same way that, say, in R2, I want to find the solution to this curve. I want to find all of the I could ask for all points. Axiom, it is well defined 2 equals 6. True. Locke, you're too smart for this stream. So you want to find all points, and that's what gives us this curve. We could ask a similar question, though. We could ask a similar question and ask about points in say RP2. RP2? Yeah. Because it's a two variable equation, right? And now this doesn't make sense, right? Because if I had suppose I had an x and a y, so if I have some well, now it's going to be like an xy and there'll be a z, right? So suppose I had an xyz that made this equation true, and then if I did something like this should be the same point as 2x, 2y, 2z, then I'm claiming that this should also be satisfied by this. I guess it's not immediately clear that this is a problem. I don't feel like doing the math, but this is one of the problems. So the way to fix this, though, is we can homogenize the curve, right? So basically, something's homogeneous. Homogeneous equation if for all the terms, the total sum of the powers are equal, right? So what we can do is just we look at the highest power and we insert what if the curve, well, too bad we're homogenizing all our curves and all our milk. I don't care what you think. So now if we take a point x, y, z and we assume that it what am I trying to say? We take a point x, y, z. We assume that it satisfies the curve. Now we look at any other representative. Then, if we look, what's going to happen? This will be lambda y squared, lambda z minus lambda x3 minus 7 lambda z cubed, right? But this is just going to be, we'll have a lambda come out in front of our original equation, and that's still going to be 0. So now the solution set is still well defined. You're going to try doing something level, okay, fine. Okay, fine. Yeah. I probably shouldn't have taken this approach to this roundabout way. I was about to tell you about points at infinity, but fine, whatever. Uh, what was I talking about before all of this? Um, oh yeah, second derivatives. Uh, second derivatives. No, we're fine with this. Let's go look at the heat equation. Let's go look at the heat equation. What the Interesting. So the wave equation, right, the wave equation, it's equal to one time derivative. Or it's a two-time derivative equal to one spatial derivative. The heat equation is one time derivative equal to two spatial derivatives. Non-trivial linear maps. Oh, that's the map. That's the thing I didn't help you with. Okay. Non-trivial linear maps preserving p-norm. Okay, fine. Let's do it. P-norm on Rn or Cn or Rn? Rn? Well, non-trivial linear maps preserving p-norm. Well, for p equals 2, it's easier. Oh, p, yeah, and you want p strictly bigger than 2. Okay. Well, let's choose an integer first, so maybe p equals 3. Zafar, what are you doing? What are you asking about kryptonite? What the? Now you're not even doing math anymore. Now you're not even doing math anymore. Why are we heat equationing? Well, because that's another important differential equation. I want to understand why it is. Wait, what is Superman's kryptonite? It's kryptonite. What? Is this some? This is a joke? Are you asking what his Achilles heel is? Kryptonite. And his kryptonite is his kryptonite. I can do it with just Rn and positivity 2. The trivials are permutation matrices and multiplying by p roots of unity. Interesting. But you want to like is it a group? Yeah, I guess if one preserves and they're compositional preserve. If one preserves it, but is it closed under inverses? Yeah, I guess it is closed under inverses, right? Interesting. Let's try P3 on R2, say. So what are we looking for? We're looking for, so I want a matrix A, B, C, D so that, let's see. How could we, I mean, the P norm, we should be able to express this with a matrix, right? It should be XY, say A. No, maybe I want these to be different letters, maybe. Alpha, beta, gamma, delta, that's a bad choice. You get a bunch of equations in the matrix coefficients. Hello, QB. what are we doing? XY. We get XY times alpha Z plus beta W, gamma Z plus delta W, and that will be X alpha Z plus beta W plus Y gamma Z plus delta W. But that should be, we want this to be equal to the P norm, which will be, wait, P norm, not the inner product. What am I doing? The P norm, not the P norm. Okay, sorry. Right. So I want x3 plus y3 to the third to be equal to a, b, c, d, x, y, ax plus by to be equal to ax plus by3. Yeah, this is awful. This is not the way I want to do it. I was hoping a small example might help me get a handle on things. The way you were going about it was showing that all equations imply the columns have disjoint support. The equations you get turn into a bunch of inner products. Oh yeah, we could remove. I see. Yeah, we could remove the 1/3 exactly. Yeah. Interesting. Actually, I wonder. Do we know? Is this a Lie subgroup? Will this be a Lie subgroup? So maybe that could help. Maybe if we saw that this was a Lie subgroup and then computed the Lie subalgebra or something and linearized it, maybe that'd make our life easier, right? Is this a Lie subgroup? I mean, preserving a norm, it's an algebraic. I mean, it's kind of is that an algebraic condition? It seems like it could be, right? It seems like it could be. It's a bunch of smooth equations. It could be, right? Yeah. I wonder then, but how do we turn this into, the thing I was thinking about, the thing I was thinking about before was trying to turn it into the matrix equation, for SO or something. You just get X times X transpose equals the identity. So if we could turn it into some equation like that, that would be nice. I guess that's what you said you were trying to do. So one thing I kind of want to do is just plug in some basis vectors and see what happens, right? So what's one thing that we need? If we plug in basis vectors, we get what? 1. So we need a cubed plus c cubed has to be equal to 1. And we get 1 is equal to b cubed plus d cubed. So those are some necessary conditions on A, B, C, D. Of course, we have the determinant is non-zero. Oh, I wonder, yeah, can we impose, like, yeah. Hmm. Mm, yeah, I don't know. What else do I, what are some other nice conditions I can get? For mass-loss theorems in shambles. Believe an argument basically using combinatorics of inner product equations gets it in general. Yeah, what were you saying about the inner products? That all equations imply columns have disjoint support. Yeah. Yeah, what if we try some like upper triangular things? Like if C right. So let's see. Let's try and do some like if we take C equals to 0, then that implies that A cubed is equal to 1. And if we're in the real numbers, for example, then that we have to have that A is equal to 1. We have to have that A is equal to 1. So we get 1 B D. And I wonder, does this completely, to what extent does this determine the rest of the matrices? So if I rewrite this out, so we have x3 plus y3 is equal to x plus by3 plus hello Costa Kachari, how's it going? Plus y3 no plus plus dy3. Squaring is product of matrix coefficients. I'm still confused. What do you mean? Or rather C1 squared C2? Where these are the columns? Expand the cubes and see what equations you get. Okay. You mean expand the full cubic equation? You get A and B in terms of each other, and you'll get a contradiction assuming B or C is non-zero. Wait, so B and C have to be 0? Really? B and C have to be 0? Interesting. Okay. Do I want to write this out? So what do we get here? What do I get here? I got a binomial. If A is non-zero, B is 0. Okay, hang on. Guess I got a binomial this bad boy. So what do we get? A 3x3 plus 3 A b squared xy squared plus 3 a squared b x squared y plus... This is a nightmare, Leo. How am I supposed to see anything from this? How am I supposed to see anything from this? b3y3. What? They separate out? What do you mean? What do you mean? What do you mean? What do you mean? Like you'll get a times b squared is 0? Why does that have to be 0? The xy squared term has to be equal to 0? Why? I guess, I see. I guess because if you just choose enough, you can just choose, you get this from the equation. Why is the inner product? But why is the inner product of those things? And what is C1? C1 is the first column. What do you mean by C2 squared? How do you square a column? And where does that equation come from? But what do you mean by C2 squared? How do you square a column? And why is that equation hold? And what do you mean by... Oh, you mean you're literally squaring entry y? But what? Why? It comes from the xy squared coefficients. But also why? Because I guess it's a... I see. It's a polynomial in x and y. I see. But wait a second. So doesn't this... I mean, I see. So you're saying that... Right. So this should completely determine everything. So we should have this in general. Wait, why is it AB squared plus CD squared? Wait, what? Why are you... What? Huh? Oh, I forgot to write out... Yeah, I see. I forgot to write out the other terms. I see. Okay. I see. Plus... plus c cubed x cubed plus 3cd squared xy squared plus 3c squared dx squared y plus d cubed y cubed. I see. Hey, Leo, here's a quick question. Why the hell are we doing this? What led you to this stupid thing that I hate? A squared b. Yeah, what is the point of what we're doing, Leo? I demand an explanation. Maybe you said it earlier, but I demanded an explanation. Okay, so we have a complete set of equations. I see. Right. Okay. Yeah, what are we even doing? What's the goal? What are we trying to do? And why? The A and B are a matrix. They send people were ratting on you earlier. They said you were cheating on me with another streamer. That's what they said. I didn't say it. I didn't say it. That's what they said. Um, it's from Scott Aronson's quantum computing book. You think the goal is to learn quantum mechanics? Yeah, but what are we trying to get at the end? What are we trying to get at? What are we trying to do? We're trying to completely characterize all of those. We're trying to completely we're trying to completely characterize all of those matrices. His hint is to literally do the. Hang on, is p even an integer? Because I was gonna say, what about the non-integer case? Is p an integer? Is p allowed to be an integer? Because when you said p norm, I thought, I mean, we do it in general. P is any real number bigger than 2. But what is the actual question? What is he? Okay, p is an integer. Okay, I guess that makes life easy. But what's the actual? Sorry, what is the question? Non-trivial maps preserving p norm, right? But what does he want? An explicit set of generators for this group, or what? What are we trying to do here? The equations are nicer if you write them in inner product form. I'm still not sure. Show non-trivial elements? Oh, that's it? We just need to show there's non-trivial elements? Well, that's a lot easier. Just do it, but with like where the trivial ones are generated. I see. The goal is to find ones that are not permutation matrices, that are not generated by permutation matrices or p-rates of unity. I don't know. Yeah, compute the Lie algebra. I don't know. Compute the Lie algebra. Integral? What are you talking about, integral? Locke, where do you see an integral? But what do you mean inner product? I'm still confused about where is the inner product coming from? Like you said, we take the inner product of these column things, but yeah, I don't get it. Up at the top? I don't know. Okay. I don't understand what you're trying to tell me, Leo. Did I actually watch the AI video fully? Which AI video? You mean the one from like 2 weeks ago? About the physicist by Cool's World? Yes, I did. Yes, I watched the full thing. Okay, so we have this equation. Why is that an inner product? Like, what's the general process for turning, like, say we're in the n case. Why is this an inner product? Oh, I see. What is my stance? My stance on what? AI? Or Yeah, I'm not sure. I know exactly what you're asking. My stance on the video, or you have a bunch of equations that by doing some casework implied disjoint support, but you haven't done. Yeah, what is? I also don't know what you mean by disjoint support of the columns. What's the support of a column? What's the support of a column? You mean the? I mean, you mean taking inner products with respect to that column? The function defined by taking inner products with respect to that column and looking at the set of vectors which makes that non-zero. If it's a row vector, the support is just the non-zero indices. My yeah. My stance on that video. It's a interesting video. I don't know. Uh, I support that video. I don't know. My stance on that video. I know Rn is a function from n to r. What? You mean an element of Rn is? Wait, what is a function from? Wait, the set n to. Wait, what? Leo, what are you saying? But hang on, I'm also trying to think about what to say about my stance on this video. I don't know. It was also 3 weeks ago, so I'm trying to remember, or 2 weeks ago or whatever. I'm trying to remember. I don't know what to say. Uh, yeah, I don't know. I don't know what to say. I don't know what to say. I don't know what to say. Right. Rn is functions from n to r. Sure. Sure. Were I not horrified by the smartest physicists being so stupid on AI? What do you mean? Were they being stupid on AI? What part did you think they were being stupid on AI? What part made you think they were being stupid on AI? The fact that some of them said they felt that AI was smarter than them. Yeah, I mean that's a weird statement. Again, I mean, we already saw that for the video. That's not from the rest of the video. That was something. Were you the person that mentioned that video to me? Um, yeah, I don't know. I mean, first off, as the guy says in the video, these physicists, the people there, also have the most professional models. They're not using like the free chat GPT like I am. So um uh they definitely have access to much more powerful things. um I mean, also, okay, so he said that they said that it does better math than humans. I don't know, that might be a bit of paraphrasing. um and they use it directly in their research. Well, okay, that's not shocking at all. People are using GPT directly in their research. That's not shocking at all. I recommend going reading. Where did I put it? I put it somewhere here recently. Daniel Litt's recent article on all of this. Um, so there's this interesting Reddit post, uh, and and so Well, here's this quote from Daniel Litt. Uh, Probably a much more grounded. Anyway, go read this post from Daniel Litt on Twitter, and go read his line. I didn't read the whole thing. No one's got time to read all that, but I don't know. Um, Also, this very interesting Reddit post recently. Uh, it finally happened to me. Recent Reddit post about using some of these recent models. So first off, yeah. So the thing is, you point out, you said they said it does better than humans, and they use it directly in their research. Okay, so using it directly in their research, I don't know. At this, but nothing is. I don't know what's horrific about that. Uh, that's just a fact. And then, okay, it does better math than humans. Yeah, the Cool's World video, he did say something like that. He's also paraphrasing from these physicists. And, I mean, who knows? They might have literally said those words, but, um, okay, obviously these things aren't autonomously pumping out research papers, right? But, like, okay, there's a lot of, even, a couple months ago, I had an experience where, there was something I was working on for a while. I came up with a solution to it. You know, After I came up with the solution, I went and I asked a non-paid model, just a basic AI model. I was like, "How would you solve this problem?" And it instantly came up with the solution that I did. Um, so I don't know. I will not try p equals 5. That sounds terrible. In general, you get those equations. Interesting. Interesting. That's what the equations are? I'm so confused as to exactly why that's the case. But I wonder. I wonder. I do wonder if there's an easier okay. So I guess the thing is still we want to produce non-trivial solutions to this. So probably you could do it enough from those equations. I'm also, for some reason, I want to compute the Lie algebra of it though. That's the same guy from Vey conjecture series on YouTube. Wait, who? Who's the same guy from Vey conjecture series? I mean, there's probably a million Vey conjecture series. Who are you talking about? AGI only exists if IQ is measuring something materially real, and not something contingent upon a pure social construct. Uh, I don't know. There's so much I don't agree with in this statement. First off, what do you mean by AGI? What's your definition? Um, Secondly, it appears your definition depends on IQ. I've never heard anyone give a definition that depends on IQ. Um, and then you're also saying, since you're saying if IQ is measuring something materially real and not something contingent upon a pure social construct, I'm reading between the lines to interpret that you believe that it is a pure social construct, whatever that means. I mean, what isn't a pure social? You could argue anything's a pure social construct. Well, maybe not the sun. Even that, you could argue the sun's a pure social construct. So I don't know. I don't. I'm not sure I vibe with that comment there, Sawdust. Before AI, there are other tools that have already made people reduce their ability to think. Yeah. Yeah, I don't know. Um, will AI drastically reduce people's ability to think and reason? I think it will for some people. I think it will for some people. Yeah. When the advantages of AI for math is that you could make software for it to check that it's correct. Yeah. I mean, I was, yeah, yeah. I've definitely used it to whip up some code faster than I could have, and it was very useful. It might be only good at proofing in the long term. Just picture what is the coefficient of x to the m, y to the n. I still don't really get it. What's the... A, C, B, D. Oh, okay, I understand. But is that true for the... Oh, you're right, Leo. Okay, I see it. I understand. Um, I understand. Right. Uh-huh. So it'll be the sum. Of... Right. The column, so we choose like column... It'll be equations, column I, entry J, column, or say K, entry K. It'll be, column, I, column J, summing over the kth entries, and then one of these will be like to the nth power or whatever, or pth power, I guess we could call it. Right. You said roots of unity. Does that mean you're doing this over the complex number? I mean, if it's over the complex numbers, couldn't we just like set all of these to be equal to 1? And then like fundamental theorem of algebra to get a non-trivial solution? R1 is just a level. It's like a, he's at a higher up university. I don't know. It means he's a smart boy. A little smarty pants. A funny bot can only exist if and only if funny is materially real. Here's where you stand. The people who sell AGI are selling a product which ostensibly reproduces human intelligence, if not exceeds it. You're in the camp that everything is indeed socially constructed, except for things like the sun. Okay. What we call intelligence in ourselves is not as general as we'd like to think. Well, what do you mean by that? What do you mean it's not as general? How general do we think intelligence is? And what do you mean by that? And the robots we build to mimic our intelligence will reproduce social structures. Okay. Maybe. It makes sense that they could. The people who sell AGI are deeply invested in the idea of IQ being transcendentally true / real concept. I mean, what does it mean to be a fake concept, though? And I'm not sure if I agree with you there. Again, I've never heard anyone bring up IQ in conversation with AGI. And what do you mean by a true real concept? Like we can do the people who sell AGI think intelligence is as universal as Christians think God is. Maybe I definitely am a fake concept. But I don't know. Is that true universally of the people who sell AGI? I don't think that's universally true. I mean, maybe that's true for some of them. And you know that AI isn't intelligent? Well, what do you mean by intelligent, and how do you know that? What do you mean by intelligent, and how do you know that exactly? And also the thing is IQ. I mean, sure, some people oversell the importance of IQ, but you know, there's no shortage of studies showing that IQ correlates with all sorts of outcomes in one's life. I mean, we can draw graphs and see a correlation between IQ and salary outcomes or something. So that seems like a pretty real thing to me. Um, depends what you mean by real, I guess. As an actual philosopher, there's a party going on in the chat. Yeah. As a no- as a fake philosopher, I also think there's a party going on in the chat. There's been a lot of rage bait posts on Reddit like that in the last few months. Yeah, I don't know. I don't. But that Reddit post doesn't seem all that crazy to me, Ken. And to be honest, it's not all that different from my own experiences. I don't know. Um, yeah, and social construct. I mean, calling something a social construct doesn't mean it's disjoint from reality. I don't. I agree with you there, Christian. Yeah. Yeah. LLM more like fancy word predictor. Yeah. How's that different from a human? I don't know what Leo was saying no to. Funny is produces laughter, therefore exists. Yeah. In complexity theory, we have various notions of intelligence. Yeah. What are the? Wait a second, I missed a question here. What are the indices under the sum? It's just it's a sum from k equals 1 to n. This is the kth entry of the ith column. So maybe I mean I don't know why I should have called it. Should have just been this. I don't know. I was just writing it stupidly there. We were building AI using our own human definitions of intelligence. Sure. But that's because I don't know what a bonobo's definition of intelligence is, so it's kind of hard to use it. Um, I mean, IQ is IQ. IQ is a number that you get when you. I mean, it's your relation to the average of a particular kind of test. That's what it ultimately is. This is the first time you're giving K on a pass on what do you mean? Because what do you mean by intelligent is an important question, yeah. Um, Although IQ does correlate with a lot, as such, it also gets confounded out with a lot of stuff. Yes, absolutely. Absolutely, yeah. It does correlate with socioeconomic status, yes, and yes, we should ask ourselves about cause and effect. The Stern-Borcott tree in connection to Ford ferry tilings of PSL 27. I don't know much about it, but maybe I'll talk about it tomorrow. I have to go. I've been streaming a long time today. I got to compete with this Sylvester Franklin fellow. A math consultant for one of the big AI companies. Really, Ken? Damn. How the hell do I get me one of those? You are a super cute word predictor, Leo. I agree. Well, I don't know. What do you mean by universal? Well, I have to go, so I'm tempted to. I want to ask what you mean by universal in intelligence. Um, 'Cause I don't know whether I should or shouldn't believe in that, but yeah. Anyways, I do gotta go for real. Um, yeah. Anywho, PSL 27. Oh, and what else? I should write down other words. The other words: Stern, Borcott. Stern, Brocott, and Ford Ferry. Okay, I will write that down, and I will see you all in the future. Woo! QED!